In this 2020 review, we've pointed to a few areas of astronomical research that need a better look with a telescope larger than Hubble. These include exoplanet formation exploration, like finding out what happened to Fomalhaut b, star and planet formation in places like the Trapezian cluster in the Orion Nebula, the age of stars in the Milky Way central bulge, and the search for first-generation population 3 stars, just to name a few. That telescope is the James Webb Space Telescope. It is almost 3 times the size of Hubble. It has been in development for over a decade and is scheduled for launch in 2021. It's optimized for observations in the near-infrared. We'll cover its key components and where it will orbit. We'll finish with a deeper look at 2 areas of investigation that Webb will probe: galactic dust and the makeup of the early universe. Here are Webb's primary and secondary mirrors. The primary is the size of a tennis court. This animation shows the light path through the telescope. The light reflects off the primary and is focused onto the secondary, where it is beamed into the camera. Webb's mirrors are covered in a microscopically thin layer of gold, which optimizes them for reflecting infrared light. Other key components include the cameras, the sun shield, the solar panels, communications antenna, the computer, and spacecraft control. The sun shield is particularly important because of the telescope's extreme sensitivity to heat. Webb primarily observes infrared light, which can sometimes be felt as heat. Because the telescope will be observing the very faint infrared signals of very distant objects, it needs to be shielded from any bright, hot sources. This also includes the telescope's own electronics equipment. It operates at 233 degrees below 0 Celsius. That's minus 388 degrees Fahrenheit. That's cold enough to freeze nitrogen. The shield can protect against temperatures on its hot side as high as 85 degrees Celsius. That's 185 degrees Fahrenheit, a little under the boiling point for water. If either the sun, Earth, or the moon are on the cold side, the telescope won't work. So to have the sun shield be effective protection against the light and heat of the sun, Earth, and moon, these bodies have to all be located in the same direction. This is why the telescope must orbit at the L2 Lagrange point, 1.5 million kilometers from Earth. That's 1 million miles. You'll recall from our coverage of Lagrange points in our How Far Away Is It segment on the solar system that objects can, with a little assist, orbit L2. This animation shows how this will work. To remain in orbit around L2, Webb will have to periodically burn small amounts of fuel. This puts a time limit on the usefulness of the telescope at around 10 years.